All right, so hopefully you have taken geometry in high school and you've also taken algebra. And then maybe you've taken trigonometry. And I said that you didn't need to know anything about trigonometry for one of my classes. There's only one time in astronomy where we use anything having to do with trigonometry. So basically, don't worry about trigonometry. And absolutely positively, do not worry about calculus, okay? But I wanted to talk about it just so that you can see that it's not so so difficult that you would just say, "Oh, I'm never going to take a calculus class," but you might. And so this is just an introduction to what calculus is all about. And you may not understand some of this stuff. That's okay, but I just want to show you some of this. Okay, so what is calculus? So calculus is a branch of mathematics that describes systems using formulas. So you have some kind of a system, and then you can represent it mathematically using calculus. And then once you have this mathematical description of a system, you can analyze that system by also using calculus. So there is two main parts to calculus: taking derivatives, and so there's the symbol for derivative. So it's the derivative of y with respect to x. Now I'm going to show you what that means here in just a few moments. And then also you take integrals of formulas. And so this thing here is called an integral of y and then dx on that. So I'll show you what do I mean by these kinds of symbols here. Okay, so first let's talk about what is a derivative. So taking a derivative of a formula finds out how it changes at a specific point, and it's related to the slope of a formula. So in this picture that you're given there, it has the graph of a particular formula. So if the formula was y equals mx plus b, then the graph of it would look like a straight line, like that. And then this would be the b down here. And notice that no matter where you're at on that line, it always has the same slope. What's the big deal? Where slope is going to be rise over run. So let me write that down here, that the slope of a graph is going to be rise over run. And in order to do that, you need to have 2 points. So let's say that you pick this point right here and then this point right here. Now this is going to be the y-axis, and then this is the x-axis. And then what you do is you come down to here and you come down to here, and then that's going to give you like x1 and x2. And then over here, this is going to be y1, and then this one over here is going to be y2. And then what do? Well, you subtract these two numbers, and then that's going to be the rise. And then you take these two numbers and you subtract them, that's the run, and then you divide them out, and then that's going to be the slope. So as long as it's a straight line, there's no big deal about finding the slope. But what do you notice about those pictures there? You'll notice that it's not a straight line, it's a curve. So in this one, you've got something that's going up and then it's coming back down again, something like that. So it's not a straight line. But let's say we want to find the slope at a particular point. So in this one here, it looks like the point was right here. So we want to find the slope of the line at that particular point. Well, if I choose, okay, so I need to choose two x's. And I'll choose, let's say one over, let me choose one over here, and then I'll choose the other one over here. Okay, so there's my two x's, but notice that would give me a slope like that. Okay, but what about if I chose to use this x over here, and I'll use this x over here? Well, can you see now that that gives me a different slope? So depending on which x's I choose, I get a different slope at this particular point. But the closer I get my two x's together, the more closely the slope approximates the correct slope. So the idea is that we want to pick our x's on either side of the place we're interested in as close as possible. And then that makes the slope more and more accurate. Well, what is the closest that the 2 points could possibly be if they're on top of each other? So this slope here, okay, so this slope would be change in y over change in x, whereas the derivative is the dy over dx. So what we're going to do is we're going to take this one, which is the average slope, and we're going to turn it into this one by making this delta x go to 0. We call that a limit. So therefore the derivative of y with respect to x is the limit as this interval, which I call a, goes to 0. And then, okay, so look at the part that's right next to it. So it says y at x plus a minus y at x, and then divide by a. Well, the top part of that fraction is the rise. The bottom part of the fraction is the run. So it's just the base, you're just basically taking a slope. But you have to take it in the limit as a, that interval, gets smaller and smaller and smaller. Okay, so let's do an example of how we might do this. Okay, now, this is going to look terrible. So if you look at this, you can see that it looks pretty bad. So our formula that we want to analyze is y equals x squared. So y equals x squared. So this y is going to be the y in there, and then this x is this x right here. So we're going to take the derivative of y with respect to x. Okay, so first we're going to write down the definition of the derivative. So it's the limit as a goes to 0 of the formula evaluated at x plus a minus x of y of evaluated at x, and then divided by a. Okay, so I take my formula here, and instead of the letter x, I substitute x plus a in there. And see, remember it's squared. So that's the first part. And then minus x squared. And then divide by a. Okay, now the next thing I'm going to do is, you should know from algebra that we can multiply this out. So that this thing is equal to x squared. So what we're doing is we're taking x plus a times x plus a. So x times x is x squared, and then plus 2ax, and then plus, this is really bad, and then plus a squared. So you should remember that from algebra. Okay, now notice that the x squared minus the other x squared is going to cancel out. So that piece disappears. So now all we've got then is this 2 times ax plus a squared divided by a. All right, and now we want a to go to 0, but it turns out that a squared goes to 0 faster than what a does. Trust me. So that means that we don't need to worry about the a squared part, and we can just get rid of it. So now what we've got is 2ax divided by a. The a's cancel out, and you're left with 2x. So what did we figure out? That the derivative of x squared is equal to 2x. That was pretty complicated. Sorry about that. So what mathematicians have done is they have calculated the derivatives for many, many different formulas, and they put them into tables. So here is some of the main derivatives that are used in mathematics. And so if you take a calculus course, for the first 4 weeks of that calculus course, you will be doing this kind of stuff, which is really, in my opinion, very boring. But it's necessary to learn how to do it from scratch. Then for the rest of the course, you can use these nice, simple equations in order to solve the problem. Now, what do I mean by that? All right, so let's use the table to solve the same question. So y equals x squared. Find the derivative using the table. Okay? And so the one that we're going to use is this one here. The derivative of x to the nth power is equal to nx to the n minus 1th power. Now, what is the n? So the n is 2. So we're going to substitute 2 for the letter n, and then what does it turn out? So 2 times x, 2 minus 1 is 1, so it's 2x. So do you see how simple it is? Well, if you want to call this simple. So this is much easier to do than all of that. And so that is part of calculus, is taking derivatives. Okay, I hope that you're coming back. So in our next segment, we're going to talk about what is an integral.